Welcome to everyone who has joined us today. My name is Gary Lewis and I'm the Marketing Manager here at Mitsubishi Electric. As we continue through our We Know series of webinars, today we're looking forward to sharing with you what we know on the advanced features of HMIs. If you'd like to ask a question during the session, you can do so by using the panel to the right of your screen. Please check as this could be minimized, and we will answer as many questions as we can at the end of the session. Any questions we do not get a chance to answer, we will answer by email after the webinar. I hope you enjoyed today's session. I'm now going to hand you over to Paul Judge.
Thank you, Gary. Hello, everybody. As Gary suggested, my name's Paul Judge, and firstly, we'd like to thank you all for joining us for this webinar session on enhanced features of the GOT HMI products. This is part of a series of webinars under the We Know banner. Just before we get started, we'd also like to thank all customers that have attended the previous webinar broadcast. The last session, along with all others, are available to view from the back catalogue, located at the indicated address. Thanks also to those that have already revisited some of the earlier sessions. So this session has been requested to provide an overview of some of the extended features of the GOT2000 range of HMIs. GOT stands for Graphic Operation Terminal and is our family name for our HMI products. Given the widespread of delegates and the available time, we will not try and cover any one topic in great detail, but if any of the features are of interest, then simply let us know and we'll arrange something suitable by way of follow-up. The content of this slide has been debated in much detail over the years, especially the areas of overlap between SCADA and DCS. For the purpose of this session, it's merely used to provide some graphical representation. It is, however, relevant as in addition to new projects, there are many opportunities to cost-effectively upgrade many legacy installations to help with the collation of meaningful data and thus provide users with valuable information. Even in the early days, SCADA would have often been deployed more for collecting and storing data than the supervisory element. Modern day DCS suppliers have aimed to provide their solution to be much more scalable to compete with growing PLC-based options, which now have modern enhanced networks and improved safety capability. Dedicated PLC processors and instructions create more powerful options than were previously available for process-based applications. The Mitsubishi IQR follows on from the very popular modular Q series products. Using the proven product pedigree provides a baseline for such solutions, thus all making systems completely scalable. This starts from just redundant power supplies and escalates as applications dictate. This topic will be covered in more detail during a future session. Again, SCADA still very much has its place for providing control solutions. For the right application could very well be the right solution. Sorry if that sounds a little obvious. But for example, the quest for data has far from stopped. In fact, it's even greater today than ever. So much so, we now have data scientists who are employed to derive intelligence from available data. Many SCADA systems themselves have also evolved, as indicated into information portals. Another noteworthy point relates to the facility provided by data servers themselves, the ability to store vast amounts of data and providing variations of redundancy between respective SCADA databases. I'm sure again this will form a topic for another webinar. Nowadays there is far more overlap and advances in screen technology and software enabling much more use of touchscreen devices. These are all very much now part of our everyday life. So let us now explore some of the features available from modern day HMIs, probably the area with the most significant evolution. These examples of core enhanced features are applicable across the range of products, including the entry-level 3.8-inch screen, and thus provide the backbone for most applications. In addition to the specific hardware models, the core HMI functionality is also available as a software application for use on computers or industrial computers. The first thing we notice is the useful addition of standard SD memory cards, thus providing a facility for storing much more data. be it the application, the project and resources, log data or alarm information. If the project is loaded onto the SD card, then the terminal can be configured to boot from the card. This, for example, proves most useful if wishing to update remote machines, especially in areas where there is limited computer resources. In certain cases, we can also use USB memory sticks, but by comparison, these are now seen as more temporary in their deployment. The backing up of any site resources should play a significant part in any company's disaster recovery plans. Users may simply use the GOT to back up or restore the programs and parameters of programmable controllers, CPUs, or other devices. With the backup of the data in the GOT, there's no need to use a personal computer. With some larger network configurations, like variable speed drives and servo amplifiers, can also be backed up via the PLC. Besides making backups of multiple controllers connected on Ethernet, you can specify a trigger device, a day a week time for automatic backup to reduce the time needed to back up each controller separately. This is a discipline that we actively encourage. When customers have such backups available, as without such steps, it greatly impacts on the downtime of machines in the event of errors. For both data and alarm logging, a simple dialog menu is presented. This enables us to select the target devices, and then users can decide if they wish the samples to be based on time or event logging. The file sizes can be configured to make the collected data more manageable. By default, the type is binary, which proves extremely useful in reducing any manipulation of the archived data. However, an additional CSV text file can be created for viewing the data in standard spreadsheet packages. FTP, File Transfer Protocol, is integrated in all of the HMIs and provides the facility to act as either an FTP server or FTP client. As a server, users can simply log on using, say, Windows File Explorer, and after entering the username and passwords, read and write to and from the HMI. As a client, the HMI has the ability, say after completion of a part or process, to send the required data to a local FTP server. FTP is a very low-cost option, but as indicated, can be automated and becomes a very powerful solution. The GOT can display comments by reading comment text files that are saved in data storage, either in the HMI memory or again from the SD card. You can edit the comments without the screen design software, which makes on and off-site work much more efficient. When creating comments for different languages, simply save them in separate columns. This enables you to readily switch languages just by switching column numbers. The larger GOTs support up to 4 communication channels and the smaller screens too. This enables a broad selection of controller products to be used. Both Mitsubishi and third-party devices can be connected to the GOT. Just to confirm, the channel is a communication type, not just a device. So if it's based on a network, then of course multiple devices can be connected. This is also useful when the device itself does not have a display option, or where the information from the device is required to be more widely distributed. The very handy device data transfer utility readily enables data to be shared between the connected devices, including across multiple supplier products. Values are managed in blocks and the device is selected as required. This helps provide better management and help ensure efficient polling of the data. The data can be shared again on a time or trigger basis. Moving on to remote access. There has been a steady increase in the number of adopters for these various features. With restrictions of physical access to customer sites, engineers are providing much more assistance remotely. These facilities are provided using the mid-range HMI products, in some cases just by using built-in firmware and others by simply registering a low-cost license. VNC, Virtual Network Computing, is a system for graphical desktop sharing that allows remote control the desktop or one computer running from a VNC server from another. This facility has been available on HMIs for some time and is a very useful facility. No additional screen creation is required, but this does mean that the user experience is shared. What I mean by that is the operator sees what you see, or at the very least they are distracted by the remote user. You simply install a VNC client on a remote device, computer or tablet, and then connect to the HMI. The access is password protected and can be set up as either full access or monitor only. In most cases, it is only possible to have a single VNC client connected to the HMI at any one time, which is a noted user frustration from most HMI suppliers. In the case of our GOT products, we provide some special system registers that help you manage these restrictions. A more recent addition to the mid-range GOT products is a feature that we call GOT Mobile. This basically enables the HMI to act as a form of web server, meaning that the screen can be viewed remotely just by using devices with standard web browsers, computers, tablets again. This clearly provides great versatility. The feature supports up to 5 concurrent users, all using different device types if required, each user having username and passwords to enter. All users being able to view different screens provides a great benefit in comparison to VNC. No special web page skills are required, as the remote pages or screens are created using the tools in the standard HMI programming software. That's again making it really easy to achieve an effective display. We can then extend the GOT mobile feature to provide a low-cost ANDON display. This can be a PC with a large monitor, or modern day even a smart TV with an integrated web browser. As the display may well be mounted high up in the factory, the logon authentication parameters can be configured, thus circumnavigating the logon process. This provides a low-cost but very flexible facility for displaying manufacturing plant information. As we start to create systems with multiple devices, there is a need to ensure that the use of simultaneous operation is addressed. The GOT provides parameters to overcome this challenge, enabling seamless integration and managed operation. SoftGOT got link function. Fortunately, it's easier to configure and deploy this option than it is to say. No actual development is required. You simply point or link the PC-based SoftGOT application to HMI, and it reads the project directly from the terminal. Once loaded, you can control the GOT in much the similar way to when using VNC. However, like GOT Mobile, the SoftGOT can display different screens to that of the actual HMI. Considering how easy this option is to configure, it is extremely powerful. And as for a great low-cost option for supervisory control, since multiple modules of the SoftGOT application can be started on a single PC, multiple production lines can be monitored simultaneously. So with the single PC in the example, we have allocated an additional monitor for each production line. Thus, we are able then to individually display each line accordingly. Again, a very cost-effective and powerful option. As we have now provided methods to collect data from our plant, we should now consider ways to improve further data management. Even with the addition of SD cards, there will be applications when greater quantities of data need to be stored. For such cases, a network drive can be used as a safe destination for GOT files. Using external storage to accumulate data permits users to worry much less about the capacity limits. When the file save destination is common to multiple GOTs, there is an option that automatically creates individual folders using the GOT's IP address, which prevents files from being overwritten. Folders and file names are shown in a list on a graphical screen when using the file manager, so it is easy to copy them as needed. File types can be identified with icons, thus readily viewable at a glance. The available space is displayed and users can sort and select data, then manage files with the simple operations on the buttons as shown. The file manager can be displayed using the utility menu internal to the HMI, or can be operated in mobile screens using the GOT mobile function. This is also a good example where you may find a USB stick, which could be used to manually copy the required data file at that time. MES, Manufacturing Execution System, is a system that controls and manages production processes at a manufacturing site in order to optimize quality, productivity, logistics, and costs. The GOT communicates directly with the MES server and thus eliminates the need for gateway equipment. The GOT uses standard SQL commands to interact with the database. These do not need to be programmed, they are created based on the selections within dialog boxes. A really powerful feature of this function is the ability to write from the buffering area. This means the GOT can accumulate data and accommodate any short-term dropouts of connections, buffering data until the connection is re-established. The next two slides just simply help demonstrate that function requires minimal programming. The functionality is achieved, as you can see, just by merely completing dialog boxes. These are divided into three key elements. Firstly, creating a connection to the database. Our demo here is connected to an Access database. Other options include SQL Server and Oracle. Then, populating tags that relate to the respective controller devices. The third step, creating a specific job for the required task. The job uses fields that are required, so we simply create a select query using the product ID to select the parameters values to be displayed. This automatically then generates the required SQL text. The original logging option to create CSV or spreadsheet files provides useful data, but normally means users create a large number of files. SQL, structured query language, is again widely used in all of our everyday lives. The benefit being that users can collate large amounts of data in a single database, and then, say, create a query that produces a refined list of the required parts. The ability for users to adopt this very powerful approach to data management without SQL-specific knowledge has proven very popular. Lastly, a GOT provides a number of features that assist in the maintenance and diagnostics of machines. The GOT can record all operations performed by operators. Checking the recorded operation history helps you identify and analyze the cause of an error that occurred, possibly due to improper operation. This can then lead to making improvements, preventing their reoccurrence, and enhancing traceability. Use of the operation log function in conjunction with operator authentication records additional information of who performed the operation. Using such operator authentication enables the GOT to be used to support FDA type application, the standards covering electronic data recording of traceability information, which is required in the food and pharmaceutical industries, for example. Sample screens are available to assist users to develop systems accordingly. As previously mentioned, the operator authentication function enables management of the users who can log into the HMI. As an output of this, audit trails can be recorded and operated by setting the operation log accordingly. The GOT saves recipe information for individual products. You can select a recipe to be written to the PLC, which achieves the quick changeover for the production line. Changing recipes is easy on either a user-created screen or on the utility screen. Record selection screens can be created by users. Various functions and designs are available. Select your favorite style from the presented list and easily create an appropriately personalized screen. With the sound function, users can attach standard WAV files or create custom messages using the text-to-speech utility software. Just enter some arbitrary text in the HMI programming software to create a sound file. The speaker, be it male or female, language, pitch, and volume of the voice can all be set. Messages can be created in up to 6 languages, and you can also create sound notification in multiple languages. As you might imagine, the initial reaction to the addition of this feature was interesting, and again, we appreciate it might not be for all. However, in many factory environments, operators wear some form of ear protection. These could be fitted, say, with a Bluetooth interface that then enables clear and concise messages to be relayed to them. Alternatively, we have had applications where the output has been added to the company PA systems. The GOT can display various kinds of documents, such as manuals, data sheets, etc. You can toggle between pages, scroll and zoom in and out for easier viewing. Entering a page number easily displays a specified page from the multiple pages within that manual. You can switch displayed documents on the screen merely by changing the document ID or page number. With objects such as touch, which is numeric input, why not make it more interactive by using the controller to make the information more intuitive? When using PDF files, which can be viewed directly on the GOT, you can use the bookmark display and keyword searches so that you can instantly find the information you need. To help reduce downtime and assist in maintenance functions, we also have a number of very detailed projects that simplify the display of critical parameters and data from the control device. These are available for our variable speed drives, servo and robots. So by way of example, various screens are available, such as in this instance, the robot status monitor, data setting and predictive maintenance menu. So you can use the GOT to operate or monitor the status of the robot, start and stop the robot, and generate text-based error information. All these features can play a key role for preventive maintenance and troubleshooting. In order to assist users improve design efficiency, there are a number of sample projects available, which cover the frequently used screen features. In addition to the sample project, a very detailed supporting PDF is also provided. This gives an outline of the system and configuration, an explanation of the screens used and their specifications and transitions. Device and comment lists are also available. In the example, we open the software, click the Utilize Data button, and choose then between sample or recently edited projects. Enter a keyword in our example PDF and click Search. This then leads you to the available projects which you can use as resource data. We would hope that you agree this provides a great reference for all users, especially new users, to assist them in developing very powerful and functional interfaces. Before I sum up this session, I would just like to remind you of next week's event. Wayne and Calvin will follow up on the initial overview of the G55 legislation with this more in-depth and advanced session. Obviously, we can help you select the right products for new applications. But also, as mentioned at the outset, there are many opportunities for evolution with legacy installations. Within Mitsubishi, we have a culture to try and be seen by our customers as trusted advisors. This is often reflected in discussions regarding such applications. Working with customers to jointly understand the potential risks and developing manageable plans for both short-term and long-term migration. In this example, names have been removed and titles changed. But that aside, this slide is based on a real example and is thus an indicative example. As an engineer, I've come to terms with how slowly control equipment is upgraded in the industrial automation arena, and understand that customers should not spend for spend's sake. But looking at the application, it's clear that it has been in existence for some time. The larger A-series products were discontinued around 2006, and the comparatively newer ANS products discontinued in 2014. This helps provide a timeline. At Mitsubishi, we are really fortunate to have very reliable products, but this in itself provides less motivation for upgrade, which is fine if the risks are frequently reviewed and the assets properly managed. There comes a time, however, when the products are simply no longer available or serviceable. The network was originally based on a coax cable, and as stated, is now starting to cause some issues. If we then look at the computers, although we weren't brave enough to get too close, these are running on an old and unsupported operating system. Any upgrades here would be complicated and potentially costly. So we discussed some of the initial aims. Interestingly, from a supplier perspective, the customer was not fazed by the hardware costs, but more given the size of the project and the fear of migration, the potential impact on production. So they were very happy if the process could be migrated on a phased basis. Production feel they would benefit from more information, and the quality department, well, they want even more to help manage traceability. So a couple of questions. We asked how much data was shared between the various PLCs, and the response was very minimal. The data shared between the PLCs included some interlocking and value sharing, but the main function was to provide data back to the SCADA system. We then asked about availability of any Ethernet in the factory. It was not a surprise that there would be a usable network throughout the factory. If we stop to think, if we configured such a solution today, I doubt we would all route management data via a master-slave network, although it was great in its day. Let's have a look at some possible options. So we could start by adding replacing one of the slave nodes. Let's say, as there are some products in the system that have become very difficult to source in the A1S in the dryer panel on the second floor. Worth noting that if we do any upgrades, that the hardware that's replaced becomes potentially useful for emergency short-term replacement. At the same time, we could add a GOT. The original PLC would provide data to the master simply using link registers. So we could use a data transfer utility in the GOT to ensure that the data in the master PLC is kept up to date, so that the display on the SCADA remains intact, as does the interlocking with the other nodes. A fringe benefit is that we have now also provided an additional display. That makes it easier for production to achieve the updates they require, compared to updating the very old SCADA system that, again, understandably, nobody wants to touch. Maybe we could take this a step further, and we could add an additional GOT, or maybe even got mobile, say with ANDON. Lastly, how about we deploy the MES feature? This, we are sure, will please the boys and girls in the quality department and generate motivation for much more. Probably the biggest single benefit of this review is the limited disruption on the current control system, whilst we step by step migrate the installation. During the session, we initially looked at the core functionality, which is applicable to all of the GOT products, even the entry-level 3.8 device. These features provided the baseline for the enhanced HMI functionality. The smart web-based options showcased a number of ways that remote interaction with the HMI can be achieved, providing valuable information to all areas and departments of the manufacturing site. We then moved on to looking at ways we could manage data and were able to collect, with the pinnacle being the MES feature, readily providing data to management level SQL servers. Lastly, some essential tools to help address downtime and preventive maintenance of the plant. Our small case study also highlighting the fact that such evolution can cost effectively be applied even to legacy equipment. During our preparation for this presentation, we compared the evolution of HMIs to that of mobile phones, albeit not on the same timeline. And we all joked about, do we make calls on mobile phones? We feel that the enhanced features of the HMI products will enable you to achieve enhanced productivity and increased information from your respective processes. We hope that the session has proved of interest and look forward to working with you to address any ideas that it may have generated. Gary, do you have any questions?
Yeah, so thank you, Paul, for taking us through this subject. We have had some questions come in. Firstly, can we use object-based security on the remote screens?
Yeah, indeed. So, for example, on one of our remote access demo projects, it will enable the operator to stop a pump, but the ability to start or restart is disabled from them remotely.
Okay, thank you. Another one, is it possible when using different PLC vendors to share data between devices?
Yeah, I think we covered that one. The device data transfer utility does indeed enable you to transfer data between devices. This is really easy to achieve and proves extremely useful.
Okay, and one more. If we use the MES feature, is it possible to display database information on GOT Mobile?
That's a great question. The data from the data we integrate with the MES is based on standard HMI registers. These are readily configurable on GOT Mobile and ANDON. Must confess, something we've not looked at before. May have to add that to our standard demo. So yeah, that's a great one.
Okay, thank you, Paul. So that is all the questions we have time for today. The questions we have not managed to answer, we will respond to after the session. That concludes today's webinar, and we look forward to welcoming you next time. Bye-bye.